Algebra 1, number 5.2b, we're talking exponents, raising a product to a power. We talked about powers in the last video, and there'll be a link to that one in this one's description. When everything inside parentheses is raised to a power, everything inside the parentheses is the base. And if we have 2a to the third power, it just means a is raised to the third power, not the 2. It would be 2 times a times a times a. When we have the little 3 exponent on the outside of the parentheses, that means the entire 2a is the base. And that is multiplied 3 times to itself. So we would have 2a times 2a times 2a. This is the same thing as saying 2 times a times 2 times a times 2 times a. And we can group all the 2's together and then group all the a's together and see that we have 2 times 2 times 2 and a times a times a. We can condense this to 2 to the third power, and the 3 a's could be to the third power. If we want to simplify this, we would do the 2 times 2, which is 4, times 2 is 8, and we'd get 8a to the third power. And now the 8 doesn't have an exponent, see? Each factor inside the parentheses is raised to the third power. Now the exponent only affects the variable or number it's next to. The exponents outside the parentheses get distributed to each value inside the parentheses. So if we looked at this one, we would distribute this 3 to the 2 and this 3 exponent to the a, see? And we would get 2 to the third power and the a times a, see? And you can simplify it. Look at this one. We've got 3a to the second power, and this second power only affects the a. We think that there's an invisible 1 here, because we know 3 to the first power is 3. We can distribute this power that was raised here, this 3 exponent, we can distribute it to each one, to the 3 and to the a. When we distribute it to the 3, we imagine there's an invisible 1. It's 3 times 1, so we get 3 to the third power. The a to the second power gets raised to the third power. That's a power to a power that we learned in the last video. When we do a power to a power, we just multiply them. So it'd be 2 times 3, or a to the 6th power. See? Now we can simplify this, because we just do the 3 times 3 times 3, and the a to the 6th power tags along, because we don't know what a is, so it's going to stay as a to the 6th power. 3 times 3 is 9. 9 times 3 is 27. Simplified, this becomes 27a to the 6th power. So remember, if a factor doesn't have an exponent, imagine an invisible 1 there, okay? You're going to see that a lot. Here it happens again. This 4 is going to have a little imaginary invisible 1 here, see? So this would be 4, as the exponent is going to go to this 4, to this x to the third power, to this y to the 5th power, and to this z to the 2nd power. So we'd get 4 to the 4th power, x to the, 4 times 3 is 12, 12th power, 4 to the y to the 5th power would be 20, wouldn't it? 4 times 5 is 20, and z to the 2nd power would be z to the 8th power, see? The only way to simplify it, because we don't know what x, y, and z stand for, but we could do the 4 to the 4th power. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. We drop down the variables and their exponents, and we get 256 x to the 12th, y to the 20th, and z to the 8th power. See? And now it's simplified. Now check out this one. You might see brackets and parentheses, and I'll have a link to brackets and parentheses in this description. But this is just saying that the x is to the 7th power. Everything inside of here is the base. So that's x to the 7th power 3 times. So we got x to the 7th times x to the 7th times x to the 7th. And we know that we can just add these up, can't we? Or we could say 7 times 3. So this would be x to the 21st power. See? If there's brackets and parentheses, we can still multiply the exponents. All right? So don't get worried when you see brackets and parentheses. It's not that big of a deal, okay? And if they still confuse you, look for that link in this description. Now look at this one. We have a negative 3 x to the 4th power, y to the 3rd, raised to the 3rd power. Well, we're going to distribute this little 3 exponent to each one. Just like when you have the distributive property before, sorry, just like when we had the distributive property before, this 2 got distributed to each one, right? Because it was on the outside of the parentheses. So this is the same thing. This is on the outside of the parentheses, just distribute it to each one. So if we have a -3, and imagine it's like to a little first power here, what's -3 to the third power? It would be -3 times -3 times -3, wouldn't it? And this x to the fourth power becomes x to the 12th. 4 times 3 is 12. And then the y becomes y to the third power times 3. That's y to the 9th. And because we don't know what their value is, to simplify it, we just drop them down. But we can do these 3 negatives, can't we? -3 times -3 makes a +9 because we multiplied 2 negatives, right? 9 times a -3 gives us a -27. So our answer is going to be -27 x to the 12th y to the 9th, okay? And as I mentioned in the last video, I want you to be careful when you have a 0. 2 times 0 is 0. So if it's raised to the second power, it's still going to be 0. And if we have 2 times 0 to the 0 power, we were taught that the 0 exponent rule says that everything equals 1. Well, what is 2 times 0? It's 0, right? So what's 1 times 0? It's still 0, see? So be careful. So going along with this one, because there were 1, 2, 3 -3s, that's an odd amount of 3s, isn't it? So what we can do is we can go off this little chart. If there's an even numbered exponent, a 2, a 4, a 6, an 8, 10, 12, 14, 16, any even number for an exponent, you're going to have a positive base. We have a -2 times a -2, it's going to be a +4. And if we had 4 -2's multiplied to each other, it would be a positive base. See? The product would be positive. But when we have an odd numbered exponent, like a 3, 5, 7, 9, a 1, you're going to have a negative base. -2 times -2 times -2, well, -2 and -2 make a +4, but if we multiply it by a third negative, we're going to have a negative number. So anytime you've got an odd numbered exponent, 3, 5, 7, 9, 11, 13, whatever, it's going to have a negative base, okay? So even equals positive, odd equals negative. Any even number of negative factors gives a positive product. And it doesn't have to be with an exponent. If you did a -2 8 times in a row, like we have here, like the 3 times 3 times 3, you don't have to think of it even as an exponent. Think of it as it opened up, okay? Think of it opened up like this, or think of it opened up like this, okay? When you've got an even number of negative factors, it's going to give a positive product. And if you have an odd number of negative factors, it's going to give a negative product, okay? So don't forget, check this video's description for links to the previous similar helpful videos on this topic to get a little more help, okay? And this is the second power rule for exponents. It's raising a product to a power. In the last video, we did raising a power to a power. Now we're raising a product to a power. And as I said in the last video, there's 3 of these power rules, and this is the second one, okay? We're going to talk about division and the quotient rule in the next video. This power rule for exponents just says that that little n right here is going to go to each one of them and become a to the n and b to the n. That's all. No big deal, okay? Don't forget to subscribe if you find my videos helpful, and I hope they're helpful. And don't forget I'm on patreon.com, and you can help support me as a monthly patron, okay? I'll see you next video. Bye.